All right, so in this video, we are going to look at finding the average rate of change and what that means for an exponential function. So for a linear function, our rate of change is always constant. That is the amount that we are increasing for every x. We're going up a certain amount for y. But for an exponential function, because this is a curved function and the pattern is multiplication, the rate of change will not be constant. So we're going to look at what that is with exponential functions today. So average rate of change describes in general how one quantity changes with respect to the change in something else. So miles per gallon, miles per hour, population, people per square foot or people per square mile. Those are also measures of average rate of change. So when we're talking about this with an exponential function, the way that we're going to find it is we will have an interval, and we're going to use that interval as our endpoints, and we're going to find the slope of the line that would be created between those 2 points. And then we will know the interval because it's going to be given to us. They have to give us the interval. They're going to either write it like this with brackets, or they're going to write it in an inequality. You could see either one. They mean exactly the same thing. A is our left hand or our initial value. B is our right hand or our final value. And then we find the slope in between those 2 points. All right, last little bit of notes before we start working with this. If it is a line, if it's a linear function, it does not matter what points we choose. It could be any 2 points. It's always going to be the exact same rate of change, and that's because the slope of the line is always constant. For a nonlinear function, they have to tell us the interval, and it will always be different for different intervals. But the way that these are the same is we're still going to use the y2 minus y1 and x2 minus x1. We're still going to look at the change in y divided by the change in x. So it's still the slope formula. All right, now we're going to actually start using this. So we have the average rate of change over the interval -2 to 0. Granted, it got a little choppy because of how it printed. So it would be -2 to 0 like this. This is our start. This is our end. So I'm going to go to the table in this case. Here is the 2 points we're looking at. So I need to look at this change here, and I need to look at that change there. If you don't like having a space in between, you could always rewrite it in a different table and have -2, 1, and 0, 9. If that helps your brain, that's totally fine. Either way, we're still doing the same thing. So this is +8, and this is +2. And remember, it's always the y change over the x change. So it would be 8 divided by 2, which simplifies to 4. So that's if they're giving us a table. If they're giving us a graph, we're going to basically do the same thing, except I'm pulling points from a graph. So here my interval is 0 to 3. So I'm going to just go ahead and make a table. So I have 0 and 3. Now here, I can very clearly see what my coordinate is at 0. It's 0, 1. But I don't see 3 on my graph. But that's okay because I see that this is an exponential curve. And if I look here, I'm going from a y value of 1 to a y value of 2 to a y value of 4. And let me make this a little clearer and say y equals, y equals, y equals. So to get from 1 to 2 and from 2 to 4 with an exponential pattern, which is only multiplication, I have to multiply by 2. So the next one, which would go with 3, would be y equals 8. So I should see a point somewhere up here where my y value is 8. So I know that this is going to be 8. All right, so here going from 0 to 3 is plus 3. From 1 to 8 is plus 7. And remember, it's always y over x. It is never x over y. So this would be 7/3. It is possible that you could see this as a decimal. If they gave this to you as a decimal, of course, it would be rounded since it's thirds. So you could also potentially see 2.33. Either one of those are going to be equivalent because they represent the same 7/3. And then our last one for this video is going to be using a function. Now, I know we haven't covered this type of function in our class yet, but we do know how to take a function. If I'm given x values of -2 and 1, I do know how to substitute into a function. So what I'm going to do is I'm going to look at replacing this x piece here. And I'm actually going to do this right in my calculator. So one thing to be very careful of, and this doesn't matter what type of function you're using, if you are substituting, especially if it's a negative number, I always put it inside of parentheses, always, because I always err on the side of caution. And I want to make sure that my calculator understands that the negative and the 2 are together and they're combined together. So I'm going to do -2 squared minus 4. And I'm just going to let my calculator do all the work. And then this answer would be 0. And then I'm going to do the same thing with 1. And just because I'm a creature of, I am a creature of habit, whenever I'm substituting into a function, I always use parentheses, personally. So this is, you can't see it. This is -3. So now I'm going to look at the y change and the x change. Here I'm subtracting 3. On this side, I'm adding 3. And remember, y over x, always y over x. So my y change was -3. My x change was +3. So this rate of change here simplifies to -1. In the next video you're going to watch, you're going to look at why we would use average rate of change, and we're going to look at some word problems and some graphs that go along with those word problems.